We're working with systems of equations, and I thought it'd be helpful to get an idea of what does 2x plus y plus 4z equal 4. And we're also going to look at 2x plus y plus 4z equals 8 and how we would plot those and show them. Now, when we have an equation of three variables, x, y, and z, we're really dealing with a 3D space. So let's go ahead and put together a 3D coordinate system. And to do that, what I'm going to do is start out with what would appear to be our normal xy axes. So I'm going to go to the right and up then. And then I'm going to put a third axis, and I'm going to usually come out down and to the left at roughly a 45-degree angle. So that's what I'm going to do. I'm going to make something that looks like that. But I'm going to label this one x. This is going to be my x, and this is like coming out of the page or in the plane. You've got to use your imagination a little bit. If that's x, this is y, and then this is going to be my z. Now, our negatives part, it's confusing if we put them solid, so maybe let's go ahead and show them as a negative by dashing them. Okay, so we know the positive y is solid and the negative is dashed. We could do that for the z. We could bring it down a little bit, and so we could show our positive and our negative. Now, there's a reason why we put the axis this way. There's other fields of math that we will need to make sure it's orientated right, and it's got to do with what is referred to as the right-hand rule. So we won't get into that specifically, but let's look at how we graph these two equations. I'm going to do the top one here in red. Okay, so I'm going to underline it in red, and we're going to attempt to graph it. We're going to see how that looks like, and let's see how we do it. The strategy we're going to do is let's pretend that we're in the xy plane. If we're in the xy plane, all z coordinates would be 0. So all we got to do is we got to put our finger right over the z, and that covers the whole thing. So let's cover up the z. Is there any way I could cover it up? Yeah. How about like that? So I'm left with 2x plus y equals 4. So that's pretty easy. If I'm in the xy plane and I'm dealing with 2x plus y equals 4, if I let x equal 0, well, y is equal to 4. So I'm just going to go ahead and use my centimeter ruler on half scale, and I'm going to put a dot here for 4. Okay, so this point here now, let's label that one. That point is x is 0, y is now 4, and z is 0. Okay, so that point is on my plane. Now let's get another one. Well, an easy one to pick would be on the x. So if I let y equal 0, then x is 2. So I come out farther here, and this is where my x would be. So let's plot that point, and that would be x is 2, and y is 0, and z is 0. Now what I know is that in the xy plane, it just follows the plane, slices the xy plane along that line. So I can now connect the dots that I've used, the points on the axis, and that is going to be the intersection of this plane with the xy plane. Now all we have to do is find the intersections in the other two planes that are easy to find, and we'll get an idea what this plane looks like. So let's move on to the z. Now we know if we have x and y are both 0, it's clear that z is 1. So I'm just going to find z is 1. I'm going to go up 1 unit. Z is 1, and let's say I'm on half scale. So I really don't go up a lot. I'm just going to go up this far. And if I go up that far, that is my point, and this point is now 0, 0, 1. So I got 0, 0, 1. Okay, so those are my 3 points. Now all I've got to do is look at my plane intersects the zx plane along this line, and then finally with those 2 points I know what happens in the zy plane. So if you want to know what this equation looks like, it's a plane. That is the plane it forms. Now you have to kind of picture this. It's kind of, if you kind of look at it, it's sitting oblique, sitting out in We really can't say quadrant 1. There's no quadrant 1 anymore. But you have a picture of what it looks like. So let's see, well, what does the other one look like? Well, we notice that everything is just similar, except we have an 8. So how about if we plot the points? Let's let y and z be 0, and let's find out where on the x-axis alone that we get. Well, we see x is 4. So if we come out here and we plot, and let's use a different color now. We'll use green for this second one. So now we come out here when x is 4, we see that this is the point here. Okay, out here. And this would be the point now, would be 4, 0, 0. And the same way, I would come up here and let's let x and y be 0. Well, z would be 2. So I could scale it here, and I could find z is 2, and that point would be right there. And since those two connect the dots, I know that that plane intersects the xz plane along that line. Well, we kind of get the picture. Turns out that it's going to intersect the y at 0, 8, 0. So let's come here. We'll put our intersection point there. And we have enough information now to complete what our plane looks like. Well, what's the significance of these two planes? Well, we could conjecture something here. And in fact, if we guessed that they were parallel, we would be right. These two planes are parallel. So let me just finish labeling this last point here in the z point. So this would be 0, 8, 0, and this would be 0, 0, 2. And in fact, those planes are both parallel to each other. You'll learn later on how you find that out and how you can actually determine, for example, the area of that triangle should you have a triangle in space that looks like that. So I hope this has been informative a little bit of how you would graph a plane in 3D space given an equation that has 3 variables.